So we need to find the first four non-zero terms of the Taylor series centered at 0 for the given function, and we don't need to use the definition of the Taylor series coefficients. So Taylor series of f of x around x equals a is f of x equals f of a plus f prime of a over 1 factorial times x minus a plus the second order derivative of f of a over 2 factorial times x minus a squared plus the third order derivative of f of a over 3 factorial times x minus a cubed, and so on. So in order to find Taylor series for our function, we need to calculate f of x, which is cosine of x, then f of 0 equals cosine of 0, which is 1. F prime of x is negative sine of x, then f prime of 0 equals negative sine of 0, so it's 0. The second order derivative of f of x equals negative cosine of x, then the second order derivative of f of 0 equals negative 1. The third order derivative of f of x equals sine of x, then the third order derivative of f of 0 equals 0. The fourth order derivative of f of x equals cosine of x, then the fourth order derivative of f of 0 equals 1. Then the Taylor series of cosine of x is cosine of x equals 1 plus 0 over 1 factorial times x minus 0 plus negative 1 over 2 factorial times x minus 0 squared plus 0 over 3 factorial times x minus 0 cubed plus 1 over 4 factorial times x minus 0 to the fourth power plus 0 over 5 factorial times x minus 0 to the fifth power plus negative 1 over 6 factorial times x minus 0 to the sixth power, and so on. So basically this equals 1 minus x squared over 2 factorial plus x to the fourth power over 4 factorial minus x to the sixth power over 6 factorial, and so on. So if we write this down in a sigma notation, we get that this equals the sum of negative 1 to the power of k over 2k factorial times x to the power of 2k, where k goes from 0 to infinity. Then to find the Taylor series of cosine of x squared, we replace x by x squared, and we get that cosine of x squared equals 1 minus x to the fourth power over 2 factorial plus x to the 8th power over 4 factorial minus x to the 12th power over 6 factorial, and so on. Now to find the Taylor series of x squared times cosine of x squared, we multiply the Taylor series of cosine of x squared by x squared, and we get that x squared cosine of x squared equals x squared times this expression, then it equals x squared minus x to the 6th power over 2 factorial plus x to 10th power over 4 factorial minus x to 14th power over 6 factorial, and so on. Then we can write this down as sum of negative 1 to the power of k over 2k factorial times x to the power of 4k plus 2, where k goes from 0 to infinity. And this is our final answer.